Newton's first law of motion says that once an object is in motion, it resists any change to that. And also, if it's not moving, then it resists any change in motion. This is because of inertia. The more inertia an object has, the harder it is to move or change movement. Inertia depends on how much mass an object has. This applies to every single object. An object that has less mass is easier to move than an object that has more mass. For example, this clipboard down here is way easier to push down the steps than it is to push Seth down the steps. This also applies to phones. As you can see, I'm moving them with the same force, but this one is moving quicker. This is because this one has a lot of memes on it, so it has more mass.
Newton's second law also is very interesting. It states that force equals mass times acceleration. You see, a change in motion requires a net force to be exerted on an object. A net force is the change of the velocity of an object. The change in net force will be in the direction of the net force. Let's use my friend Bob for an example. Right now he is at rest. When I throw him up, he is being exerted a net force. So I apply a force upward and he moves upward. Now, not only does Newton's second law state that net force moves an object, but that force equals mass times acceleration. So the more mass an object has, the more inertia it has. And inertia means less acceleration. So in theory, more mass means less acceleration. You see, this clipboard is harder to move than this ball because the clipboard weighs less. When I toss the clipboard up, it requires more force to move it up. So if I apply the same force to both objects, one is going to go higher than the other. Newton's third law explains that every action has an equal and opposite reaction. So every time I throw this ball up, the ball throws me. If you don't believe that, let's use Nolan as an example. When I push him, he doesn't move very easily, so I get pushed. You see, when I pushed on Nolan, I was the first force, which makes me the action force. When Nolan was pushing on me, it was the reaction force. So pushing on Nolan was an action force. And when he pushed on me, it was a reaction force.